two students, Andy and Holly, were given the following question on an exam. A transformation is applied to the graph of y equals log x, and a sketch of both graphs is shown. Write the equation of the graph which represents transformed image. So the graph isn't like changed where it's reflected in the y-axis or anything, right? It's not reflected in the x-axis, so there's no negatives. There's no horizontal shift, because if there was a horizontal shift, a horizontal translation, this would move too, and it hasn't, correct? It's not moved up or down for that matter, but we can look at it and we can say, hey, my guess is it looks like it's possibly horizontally stretched. So if this was the original at 1, this would be what? This is at 1, 0. This is at a third and 0, because it's 1 cut into 3 pieces, right? So this would be a third and 0. So we can compare those ones first, because even if we multiplied the y by, because the y's are zeros, it wouldn't change them, right? Even if there's a vertical stretch. So we can look at these. So 1/3, and let's test this one. This is at 2. So this would be 1 times a third. So this would be 2 times a third. What's 2 times a third? 2/3. So would this approximately be 2/3? You know what I mean? When you do it this way, 2 times a third, this would be this way. It should be the same height. Is that about 2/3? I don't know. It's really poorly. About 2/3, because your x is being multiplied, right? 3 times a third is going to be what? 3 times a third, guys. That one's an easy one. 1. So if I follow it over, is it at 1? Yes. So all that's happening is you're having a horizontal stretch by a factor of a third. So it's going to be y equals log what x? Factor of a third. When we put it back in, what's it going to be? X becomes 3x. Because when it's with the variable, you flip it. Okay, I want you guys to try these ones out. Just 7, 8, and 9. 10 we'll do together. 7, 8, and 9. So whenever we hear x-intercept, we should always underline and think y equals 0. Solve for x. So 0 equals log a x minus d. If I am missing the x beside the log or in the base and I want to find it, I change to exponential, right? So we always do. So I like putting log on left to change to exponential myself. And then I do a 7. Now you can only change to exponential if this log doesn't have a number in front of it. If it had a number in front of it, you'd have to divide that number over first, right? Then change it to exponential. So a to the 0 equals x minus d. What is a to the 0? What's anything to the power of 0? 1. It doesn't just go away and be a 0. It's a 1. So I have 1 equals x minus d. Add the d over. X equals 1 plus d. C. What's the hardest part of 8? Or the biggest error? Forget to take out the 2. So we get y equals log 2x plus 5 divided by 2. Now it says the graph of y equals log x is transformed to the graph of y equals log 2x plus 5 by a horizontal stretch about the y-axis by a factor of what? What are we stretching it by? A factor of 2 or a half? A half, because it's with the variable, we flip it. And followed by a horizontal translation, q units left. 5 halves. Common answer is going to be a half plus 5 because you're going to first take the 2 out, right? So then we add them. 1 half plus 5 halves is 6 halves, which is 3. When we do an asymptote for a log, remember log graphs always have vertical or horizontal asymptotes, log graphs. Logs are either sideways. They like go like this, or they go like this, or they'll be on this side up like this, or down like this. So you always have vertical asymptotes with logs. Always vertical asymptotes. What's the only thing that can move something that's vertical? Not vertical translation, right? Vertical translation moves stuff up and down. This is a vertical asymptote. That means the only way it's moving is if it's moving to the left or to the right. What's the only thing that moves to the left or to the right? What translation? Horizontal, yes. So the only thing that's moving this is that translation right there. So how did I move it? 2 to the left. It's normally at 0. It's moved 2 to the left. Now, is that x equals 2, or x equals -2, or y equals -2? X, I already wrote it. So there we go. It's cutting through the x. It's not cutting through the y. Remember, vertical lines are always x equals. Horizontal lines are always y equals. If it says, this is a trick way they can do it, if they say it reflects about the line x equals 0, which axis am I reflecting about? Reflecting about the line x equals 0. Which axis? Y. Because x equals 0 is the y-axis. So instead of them saying it has a reflection in the y-axis, they can say it reflects in the line x equals 0. And then people are like, oh, x-axis. No, x equals 0 is the y-axis, or y equals 0 is the x-axis, right? They can make it tricky. 10 I wanted to go through with you because it's a little trick and I haven't really shown it to you. If the graph of y equals log base 7x is reflected in the x-axis, if it reflects in the x-axis, where does your negative go? With the y or with the x? With the y. So we would normally have negative y equals log 7x. And then I can divide the -1 over, and that's how I get y equals negative log 7x. And everyone is happy. And they're like, yes, praise Jesus, I have the answer. I have the answer. And then the question keeps going. The equation of the image can be written in the form y equals log cx. And you're like, c is 7, but there's no negative. Oh my gosh, what is happening? What is happening? What is happening? Okay? Bear with me. If I give you this, watch. So say I give you this, log 1 over a, yeah, x, okay? That is the same as writing negative log ax. These are the same. Now, some of you don't believe me. You're like, nah, I don't believe you. Lepp, you're a liar. So, what can I prove to you to prove this to you? Well, okay. If I'm saying this is the same as this, then what is this the same as? Log what? 1/7 x. Remember when I gave you exponential and I said to you this? I said to you that 3 to the x, if I want to compare them, y equals 3 to the x, and I give you y equals 1/3 to the x, what could I do so that I can compare them? Because right now I can't. They have different bases. I could raise this to the -1, and I'd have y equals 3 to the -x. Because I'd raise this to the -1. Now I have the same base, and they're just a reflection in the y-axis, right? This is the same. It's a reflection in the x-axis, but you change these things. If you do not believe me, put this into y1. And if you do believe me, put it into y1. And then put this into y2, but make the line thicker if you don't have colored lines. And prove to yourself it's true. Do it. You want it to. I know you do. Try it out. My calculator's still not working. For my computer. How do we put this in if we don't have the base button? Negative log x divided by log 7, remember? Okay. So if I had y equals negative log base 7x, I just draw a line like this, put a log to the bottom, and I get negative log x over log 7, right? You don't have the base button. Did you get the same graph? Were they on the same spot? Mm-hmm. No, the negative just goes to the top. Yeah. Did you get the same graph? Did it draw it on the same spot? You're all looking at me like you have no idea, so either you didn't do it or you're just not replying. It's very easy answered. Is it the same or not? Yes. So, what's my answer here? What would I put into here? 1/7? I get this sometimes, and I kind of laugh a little. There is no slash button. There's no slash bubble that you can circle, so you can't put that as an answer. It wants the nearest hundredth. What's 1 divided by 7? 0.142 would be your answer. Then flip over. Okay, I just want you to do example 5, please. These ones here. Example 7, describe how the graph of each log function can be obtained from this. Just like exponential, you can only compare logs if they're the same base. Okay, so what's this one doing? What's this 2? 2 to the horizontal translation, 2 to the right. And a vertical translation 4 up. What's this negative in front? Reflection in the x-axis, because you could put it with the y. And this is a vertical stretch by a factor of 3 because it's not with the y, you keep it, right? And this is a horizontal stretch by a factor of 1/4. Here's your homework. You have in class time about 10 to 15 minutes. So get working.